In the first video we saw that all the things in the world are made of incredibly tiny particles called atoms, and also that there are 92 different kinds of them. Most things have more than one kind of atom in them, but this nugget of pure gold contains only gold atoms. So we call it an element. An element is a substance made of only one kind of atom. Zooming back out, we see that the gold atoms become a lump of gold again. If we zoomed out from silver atoms, we'd see a lump of silver instead. Because there are 92 kinds of atoms, there must be 92 elements too, one for each kind.
You probably have already heard of some of them, like carbon, iron, and aluminium, or aluminum if you're American. But maybe not astatine or ytterbium. With so many elements, there's a lot of names to remember. Fortunately, there's a list showing all the elements. It starts with the element with the lightest atoms, hydrogen, and goes to the element with the heaviest atoms, uranium. This list is called the periodic table. How about grabbing your own copy now and check it as you watch the video? The lightest element, hydrogen, is at the top left-hand side of the table.
Each element can be written with a shorthand using one or two letters called its symbol, which is capital H for hydrogen, not surprisingly. Each element also has its own number, showing its place in this list, called its atomic number. Hydrogen is the lightest element, so its atomic number is 1. Zooming into helium at the top right, we can see that its symbol is He, big H, little e, to make it a bit different to hydrogen's. And its atomic number is 2, being the second lightest element. The third lightest element is lithium, so it has an atomic number of 3. Where's lithium? It starts the next row. This row goes up to atomic number 10 before another row is started. How many rows are there? 1, 2, 3, 4, 5, 6, 7. The periodic table has 7 horizontal rows. What about these rows down below, called the lanthanides and actinides? Well, they really belong to rows 6 and 7 and should slot into these spaces. The lanthanides are elements 57 to 71 and the actinides are elements 89 to 103. To slot them in, we have to make the periodic table wider. This full table is more accurate, and some versions are printed this way. This layout also makes it easier to see how many elements are in each row. 2 in the first row, 8 in the second, 8 in the third, 18 in the fourth, 18 also in the fifth, 32 in the sixth, 32 in the seventh. Altogether, there are 118 elements. HC.
How come? Aren't there meant to be only 92 elements, with uranium being the last one? Yes, but clever scientists have made artificial elements in the lab, like neptunium and plutonium, the elements next door, that were made in 1940. These new elements make the overall list of elements a bit longer. Let's collapse the periodic table back to its usual shape, which is more convenient for fitting onto the screen.
You can see that the periodic table is also arranged in vertical columns, which scientists call groups. How many groups are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 18. 18 vertical groups. The key point about groups is that they contain elements that are similar to each other, like members of a family. For example, all of group 1 elements except hydrogen are soft, malleable metals that explode when you put them into water. Some groups even have family names. Group 1 elements are called the alkali metals. Group 2 elements are the alkaline earth metals. Group 17 are the halogens, and Group 18 are the noble gases. Now you're ready to read the periodic table. What is the name of the element with atomic number 30? You just have to scan around and find 30. Zinc. What is the atomic number of calcium? Now you've got to find calcium on the table. 20. Which row is sulfur in? The third row. Choose any element in the fifth row. There are a lot of possible answers for this. Could be strontium, tin, iodine. You choose. Which group is chlorine in? Group 17. Choose an element in group 15. Could be nitrogen or arsenic or any of the others. Your choice. But what if you were asked which element is in row 5 and group 2? There can only be one answer: strontium. Each element has its own unique combination of row and group. Can you see the grey diagonal band that splits the periodic table into two parts?
This divides the elements into metals on the left and non-metals on the right. What is a metal? Here's a few: titanium, iron, chromium, aluminium, silver, and gold, with the atomic numbers above the symbols. Have you noticed that these metals are shiny and solid? They all are, well, except for liquid mercury.
Metals also conduct electricity and heat. Here, the different metals are connected to an electrical circuit. If the bulb lights up, it means that the thing is an electrical conductor. They all are. Metals are also malleable, which means that if you belt them with a hammer, they'll flatten into a thinner shape. Here you can see that aluminium has 3 metallic properties. It's already been flattened into a thin sheet, it's shiny, and it conducts electricity. We looked at aluminium, titanium, chromium, iron, silver and gold, all to the left of the diagonal, and saw that they all have metallic properties. What about nonmetals to the right-hand side of the diagonal? They're the opposite. Most nonmetal elements are liquids or gases, but there are a few solids, and these can be more easily tested. Here, sulfur and selenium are showing that they don't conduct electricity. Can you see that the bulb doesn't light up? And if you hit this carbon with a hammer, it smashes into bits. This is called being brittle. It's the opposite of being malleable.
Let's use the periodic table to predict whether an element would be a metal or a non-metal. How about osmium, atomic number 76? Osmium is to the left of the diagonal grey band, so it should be a metal. How about iodine? That's to the right of the diagonal line, so it's a non-metal. Let's try something trickier. Do you reckon yttrium, atomic number 39, would be shiny? It's to the left of the diagonal line, so it's a metal. So it's probably shiny. Would phosphorus, atomic number 15, conduct electricity? It's to the right of the diagonal, so it's a non-metal. Probably not.
What about the elements inside the diagonal band? Let's take a look at silicon. It looks shiny like a metal, but if you whack it with a hammer, it breaks into bits. So it's brittle like a non-metal. And the dull glow of the bulb tells us that it conducts electricity more than a non-metal, but not as much as a metal. And this gives it the name of semiconductor. These elements are also called semi-metals because they have properties that are in between metals and non-metals.
Are they more metal or non-metal elements? Metals! Nearly 3/4 of the elements on the periodic table are metals. But that doesn't mean they're more abundant, because in the Earth's crust, there are more oxygen and silicon atoms than the rest combined. And the universe as a whole is mostly hydrogen.
In fact, hydrogen is special in lots of ways. It's to the left of the diagonal, but it's not a metal. Well, it can't be. It's a gas. It looks like it's in group 1, as a member of the alkali metals, but it can't be, because it's not a metal. The truth is, hydrogen doesn't belong to any group, and it's considered to be a group all by itself. Some periodic tables even put it on its own to show this. Just remember, hydrogen is special. The periodic table squeezes a lot of information into a small space. The English writer C.P. Snow said that the periodic table took all the jumbled facts about the elements and fitted them into a pattern, and it was like turning a jungle into a garden.
My view is that the periodic table is the alphabet of the universe, whereas our ordinary alphabet is a list of letters that can make all the words in our language. The periodic table is a list of elements that can make all the substances in the universe.